Now let's look at number 3. State 2 principles from Dalton's atomic theory that have been revised as new information has become available. And this really gets to the idea of what the atomic theory is. Going back, starting with, let's just say with Dalton's atomic theory, then moving into what we will see Thomson's plum pudding model, then Rutherford's nuclear model, and then Bohr's quantized energy levels and the current quantum model. It's not as though someone is walking into the room and saying, this idea is dumb, this model is ridiculous, we have to get rid of it and get a new one, and here's a different idea, and I can just argue it better than the people could before. Is that there's a current model. It's the current best understanding of what the atom actually is. But once new data becomes available, if that new data implicates or shows that the current model is incorrect, you have to adjust the model. Now, you don't have to throw the whole thing out. Okay, that's simply not true. But you will have to tweak a little bit of it, because models are supposed to explain and even predict future data as it becomes available. So that's why we see, as new information becomes available, theories or models tend to be revised or changed, and then sometimes just completely undermined and forgotten. But specifically with regard to Dalton's atomic theory, we have to remember the 5 postulates of Dalton's atomic theory. So which of those 5? Okay, there are 2 of them have since been revised. Well, one is that atoms are divisible into smaller particles. We call them subatomic particles. Now, the reason that this won't come into play too much for us in chemistry is because it requires very extraordinary reactions for these divisions to occur. They're called nuclear reactions, and they're not an ordinary chemical thing, and so we don't really talk about them. There is a chapter in your book, and these types of things do happen on the Earth, radioactivity and things like that. And they're important topics, but we are not going to deal with them very much. We are typically going to simply concern ourselves with the rearrangement of atoms into new substances. But Dalton's atomic theory did state that atoms are indivisible. They cannot be subdivided at all. And in fact, they can. Not very easily. Okay, and we don't see it all that much, relatively speaking, here on Earth, but it can happen. Also, Dalton stated that all atoms of an element are exactly the same in every property, and it turns out we now know that they are not. Coming up soon in Chapter 3, we'll talk about isotopes. Okay, isotopes. You can have 2 elements of, or more, okay, 2 atoms of the same element, and they can have different masses. Now that stems from having the same number of protons, okay, same atomic number, so the identity of the element stays the same, but you can have a varying number of neutrons. Remember that neutrally charged particle that is also in the nucleus? Now, because it doesn't change the overall positive charge in the nucleus, it doesn't change the identity of the element. So, carbon is still carbon. Oxygen would still be oxygen. But if we have more neutrons in the nucleus, we have an atom of carbon, for example, that is heavier, okay, more massive than another carbon atom. And so we'll cover this more in depth, but when you hear things like carbon-12, carbon-13, carbon-14, you're actually talking about different isotopes of carbon. The reason that we have the different designations is they have different masses. Now, truly, it's still carbon. Okay, the exact same number of protons exist, still has the same chemical properties as carbon, still behaves the same way. It's just a little bit heavier.